So integral a to b of x dx is also equal to integral a to b of t dt. X cube minus x dx. What is the interval given here? The interval is closed interval -1, 2. Integral a to b of x dx is also equal to minus b to a of x dx. What is this equal to? Integrate it. Integral of x square is x cube by 3 between limits 1 to 2. Hello dear students, welcome to this session of mathematics class. I am Mr. Niranjan, Faculty of Mathematics, Vidhyaashram PU College, the Temple of Excellence. Now in this session I am going to discuss very important problems for 6 marks. So 6 marks questions, you are going to get 6 marks from this concept. The concepts are some properties of definite integral. So today I am going to discuss regarding the properties of definite integral. So there are 7 properties. In these 7 properties, definitely you will get 1 question for 6 marks. That is in part E. Part E, 6 marks question is from these properties of definite integral. Now let me discuss the properties. The first property, P0. The first property, what is the property? Integral a to b f of x dx is also equal to integral a to b f of t dt. That means if you change the variable x to t, then it won't changes anything. If x is changes to t, then integral a to b f of x dx is also equal to integral a to b f of t dt. Let me prove this. Now first of all, let us know what is this integration of f of x dx. Let us consider, let integral of f of x dx is equal to capital F of x plus c, an ordinary integral. Okay, now let us take here, put x is equal to t. If you put x is equal to t, then differentiate this, dx is equal to dt. Okay, now as I explained in the previous classes, whenever the substitutions are taken, the value of limit also changes. In definite integrals, whenever the substitutions are taken, the value of limit also changes. When? What is the lower limit? When x is equal to a, the lower limit is a. When x is equal to a, then this becomes t is equal to x, t is equal to a. When x is equal to the upper limit b, what happens? T is equal to x means that is also equal to b. Now come to this LHS. What is LHS? LHS, a to b f of x dx can also be written as a to b f of x dx is also equal to integral. What happens here? The limits a to b reduces to same. A to b f of x is replaced by put x is equal to t, then dx becomes dt. So integral a to b f of t dt, this is the required RHS. That's it. So integration of a to b f of x dx is also equal to integral a to b f of t dt. Suppose if you change the variable x to t, it won't changes anything. That's it. Now listen to me. Let us take x is equal to t, put x is equal to t, dx is equal to dt. Whenever the substitutions are taken, the value of limit also changes. Limit when x is equal to a, t is equal to x is nothing but a. Again when x is equal to b, the upper limit, t is equal to b. This LHS a to b f of x dx can be written as a to b f of x is t and dx is equal to dt. F of t dt, that is what the required answer. So integral a to b f of x dx is also equal to integral a to b f of t dt. Followed? That's it regarding the first property, P0. Now let us come to the next problem. Now property number 2, P1. Let us come to the property number 2. What is the property number 2? Integral a to b f of x dx is also equal to minus b to a f of x dx. That means if we change the integrals, if the limits are interchanged, if the lower limit and upper limits are interchanged, then the value of a integral will take the negative sign. That's it. Integral a to b f of x dx is also equal to minus b to a f of x dx. Just changing the lower limit and upper limit as lower limit to the upper limit and upper limit to the lower limit, then this becomes integral will reduce us to the negative sign. a to b f of x dx is equal to minus b to a f of x dx. In particular case, if the limits are same, lower limit and upper limits are same, integral a to a f of x dx is always equal to 0. Upper limit minus lower limit, that is equal to 0. Now let us prove this. Now come to the proof. Now let us take LHS. What is LHS? Integral a to b f of x dx. Now, so suppose if integration of, in general, ordinary integral of f of x dx is equal to capital F of x plus c. Let us consider the integration of f of x dx is equal to capital F of x plus c. Now integration of f of x is nothing but capital F of x between the limits a to b. This can be written as, apply the limits, upper limit f of b minus lower limit f of a. This can also be written as, write down first minus of f of a plus f of b. Now you can take negative sign out, minus out. This is function of f of a minus f of b. Now this is nothing but, what is this equal to? F of a minus f of b is nothing but minus integral of a to b f of x dx. That is the required answer. That is your required RHS. That's it. See here, minus of f of a minus f of b is minus integral f of a minus f of b is nothing but integral a to b f of x dx. That is the required answer. Hope you followed. That's it. Let me explain once again. Integral of a to b f of x dx is f of x between the limits a to b. Apply the upper limits f of b minus f of a. Now f of b minus f of a can also be written as, write down minus f of a plus f of b. Okay, if you take minus out, this is negative out, f of a minus f of b. Now if you observe carefully, this is nothing but the integral, negative sign as it is, f of a minus f of b is nothing but the integral a to b to a of f of x dx. That's it. So if you apply the formula for this, b to a f of x dx is nothing but f of a minus f of b, which is the required RHS. That's it. Okay, listen to me, very simple property. Let us take LHS. LHS a to b f of x dx. Integrate it. Let the integral of f of x dx is equal to capital F of x plus c. So f of x between limits a to b, apply the upper limit f of b minus f of a. This can also be written as minus of f of a plus f of b. You can take minus out, f of a minus f of b minus, what is f of a minus f of b is nothing but integral of f of x between the limits b to a f of x, which is the required answer. So that means integral of a to b f of x dx is also equal to minus b to a f of x dx. Suppose if you interchange the integrals, lower and upper limits are interchanged, then the integral will take the negative sign. Let me discuss one small example on this. Come to an example. Let us consider one small example. Now what is the property? Integral a to b f of x dx is also equal to minus of b to a f of x dx. Now let us take one small example. Okay, let us take an example. Integral 1 to 2 x square dx. Now what is this equal to? Integrate it. Integral of x square is x cube by 3 between limits 1 to 2. Now 1 by 3 out, you can apply the upper limit 2 cube minus 1 cube. That's equal to 1 by 3 into 2 cube is 8 minus 1. 1 by 3 into 7. This is equal to 7 by 3. Now according to the definition, if I interchange, if integral 1 to 2 can be written as 2 to 1 x square dx, then according to the definition, the value of this integral is equal to minus 7 by 3. Okay, minus 7 by 3. Let me check. This is integral of x square is x cube by 3 between limits 2 to 1. 1 by 3 out. Upper limit 1 cube minus lower limit 2 cube. 1 by 3 into 1 minus 8. This is 1 by 3 into minus 7. This is equal to minus 7 by 3, which is the required answer. So that means integral a to b f of x dx is also equal to integral b to a f of x dx along with negative sign, minus of integral b to a f of x dx. So, in this example, integral 1 to 2 x square dx is plus 7 by 3, integral 2 to 1 x square dx is equal to minus 7 by 3. Okay. Now, let us come to the next property. The next property, property number 3, P2, integral a to b f of x dx is also equal to integral a to c f of x dx plus integral c to b f of x dx, where the c lies between a and b. So, the splitting of the limits, that's it, split it. So, a to c f of x dx plus c to b f of x dx, where c lies between a and b. This is very important property. Okay. Now, let us define, come to the proof. Let integral of f of x dx is equal to capital F of x plus c. Now, let us come to the LHS. LHS integral a to b f of x dx can be written as f of x between the limits a to b. This can be written as f of b minus f of a. Now, on the other hand, right hand side, what is the right hand side? Come to this, let integral a to c f of x dx is equal to capital F of x between the limits a to c. Now, this can be written as apply the limit, upper limit f of c minus f of a. Let us represent this as equation number 1. Now, on the other hand, similarly, take this integral c to b f of x dx can be written as capital F of x between limits c to b. Apply the limits. This is capital F of b minus f of c. This is equation number 2. Now, adding 1 and 2, if you add 1 and 2, what you will get? You will get the answer. That's it. So, listen, let us define, let integral f of x dx is equal to f of x plus c. Come to this LHS, take LHS. LHS a to b f of x dx integral is equal to f of x between limits a to b is f of b minus f of a. Take these two, integral of a to c f of x dx is equal to f of x between limits a to c is f of c minus f of a. Represent it at equation number 1. And similarly, take this part, integral c to b f of x dx is equal to f of x between limits c to b f of b minus f of c. Now, let us come to the next page. Now, adding 1 and 2, adding equations 1 and 2. What are the equations? Number 1, in the left hand side, a to c f of x dx and c to b f of x dx. A to c integral a to c f of x dx plus integral c to b f of x dx is equal to left hand side. What are there in the right hand side? In the right hand side, f of c minus f of a plus f of b minus f of c. F of c minus f of a plus f of b minus f of c. F of b minus f of c. Cancel the terms which gets cancelled. So, here plus f of c minus f of c gets cancelled. What is remaining is minus f of a plus f of b. So, this is equal to f of b minus f of a. What is this equal to? F of b minus f of a is nothing but integral a to b f of x dx, which is the required RHS. That's it. So, integral of a to c f of x dx plus integral c to b f of x dx is always equal to integral a to b f of x dx. From previous page, in adding equations 1 and 2, left hand side a to c f of x dx plus c to b f of x dx integral is equal to right hand side f of c minus f of a plus f of b minus f of c. Minus f of c plus f of c gets cancelled. Minus of f of a plus f of b can also be written as f of b minus f of a. Since f of b minus f of a is nothing but integral a to b f of x ca, f of x into dx. That is the required answer. So, in general, therefore, integral a to b f of x dx is always equal to integral a to c f of x dx plus integral c to b f of x dx, provided a lies between c lies between a and b. This is very, very important property of a limit. Now, Now let us consider some examples for this. Example, suppose if it is like this, integral 0 to 2a f of x dx can also be written as integral 0 to 2a can also be written as integral 0 to a f of x dx plus a to 2a f of x dx. Integral 0 to a f of x dx, 0 to 2a f of x dx is also equal to 0 to a f of x dx plus a to 2a f of x dx. This is one example for this. If you want one more example, consider one more example. For example, if it is like this, minus a to a f of x dx. Minus a to a f of x dx can also be written as minus a to 0 f of x dx plus 0 to a f of x dx. That's it. Minus a to a can be written as minus a to 0 f of x dx plus 0 to a f of x dx. This is another example for this property. Let us come to the next property. What is the next property? This is also very important property. Property number 4, P3. Integral a to b f of x dx is always equal to integral a to b f of a plus b minus x. That is sum of these two limits. Sum of upper and lower limits. A plus b minus x. Sum of lower and upper limit minus x. Very important property. Now let us consider, let us take the proof. Let us come to the RHS. I will go to the RHS. RHS integral a to b f of a plus b minus x into dx. Now let us consider, put t is equal to a plus b minus x. Put t is equal to a plus b minus x. Differentiate it. dt by dx is equal to a plus b constant. Differentiation of x is 1. dt is equal to minus dx or minus dt is equal to dx. See here. Let me explain once again. Proof. Let us take RHS. What is RHS? Integral a to b f of a plus b minus x. Put t is equal to a plus b minus x. Differentiated dt by dx is equal to a plus b constant 0. Differentiation of x is minus 1. dt is equal to minus dx or minus dt is equal to dx. Now further, whenever the substitutions are taken, the value of limit also changes. What is the lower limit? A. Upper limit is b. These two also changes. When x is equal to a, lower limit, when x is equal to a, substitute here, t is equal to a plus b minus a. Minus a plus a gets cancelled, this reduces to b. Again, when x is equal to b, the upper limit is b, substitute here, t is equal to a plus b minus b. Minus b plus b gets cancelled here. The given integral reduces to integral a to b reduces to b to a, f of a plus b minus x. What is a plus b minus x is t. F of t into, what is dx? dx is equal to minus dt. dx is equal to minus dt. Everything reduces to integral b to a f of t minus dt. You can take minus out. Minus b to a f of t dt. Now, this can also be written as, according to the property number 2, if we interchange the limits, lower and limit, it will change as the sign. This becomes, minus becomes plus, and the limits b to a reduces to a to b f of t dt. That is according to the property. Integral a to b f of x dx is also equal to minus b to a f of x dx. Further, according to the first property, if we change the variables x to t, then this reduces to a to b f of x dx, which is a required LHS. What is the required LHS? Integral a to b f of x dx. That's it. Very simple and very important property it is. Listen to me. Integral a to b, let us take RHS. Integral a to b f of a plus b minus x dx. Put t is equal to a plus b minus x. Differentiate it. You will get dt is equal to minus dx or d minus dt is equal to dx. Whenever the substitutions are taken, the value of limit also changes. Therefore, put when x is equal to a, t is equal to a plus b minus a. That's equal to b. When x is equal to b, t is equal to a plus b minus b plus b gets cancelled a. The given integral reduces to a to b becomes b to a f of a plus b minus x is t, and dx is equal to minus dt. b to a f of t minus dt. You can take minus out, minus b to a f of t dt. According to the property number 2, integral a to b f of x dx is also equal to minus b to a f of x dx. This becomes b to a reduces to a to b, minus becomes plus f of t dt. Further, according to the property number 1, according to property number 1, that is not, integral a to b f of t is also equal to f of x dx. If you change the variables x to t, then f of t dt is also equal to f of x dx. Integral a to b f of x dx, which is the required answer. So therefore integral a to b f of x dx is also equal to integral a to b f of a plus b minus x into dx. Very important problem. You may expect this problem, this property along with one example for 6 marks, this property and an example. Okay, let me take one small example on this. Based on this property, let us consider one example. Evaluate integral 0 to pi by 2 square root of sin x divided by root of sin x plus root of cos x dx. Okay, now let us consider this as I. Let I is equal to, represent this as equation number 1. Now change x to, what is upper limit? Pi by 2. Lower limit 0. Pi by 2 plus 0 is pi by 2 minus x. So using this property, a plus b minus x, that is pi by 2 plus 0 minus x. This reduces to I is equal to integral 0 to pi by 2 square root of sin x is replaced by pi by 2 minus x dx divided by root of sin pi by 2 minus x plus root of cos pi by 2 minus x into dx. This can be written as I is equal to integral 0 to pi by 2 square root of, you know what is sin 90 minus theta? Sin 90 minus theta is cos theta, cos x divided by root of sin 90 minus is cos x plus root of cos 90 minus theta is also equal to sin theta. So in this case, this is equation number 2. See, wherever there is sin, we have cos in the equation number 2. So sin changes to cos, cos changes to sin. Now adding 1 and 2, equation number 1 is this, equation number this, left hand side I plus I is equal to integral 0 to pi by 2. Equation 1 is root of sin x divided by root of sin x plus root of cos x dx plus integral 0 to pi by 2. Equation number 2 is root of cos x divided by root of cos x plus root of sin x, root of cos x plus root of sin x. So this can be written as I plus I is 2 is equal to integral 0 to pi by 2. Take LCM. So 0 to pi by 2, here denominator root of sin x plus root of cos x is one and the same. Root of sin x plus root of cos x in the denominator. These two gets cancelled. In the numerator, you will get root of sin x plus root of cos x. What happens? This entire step gets cancelled. Integral 0 to pi by 2 into dx. So integration of dx is x between the limit 0 to pi by 2. 2i is equal to, apply the upper limit, pi by 2 minus 0, this is equal to pi by 2. Therefore, only I is equal to pi divided by 4. That's it. Very easy and very important problem. Whenever a problem like 0 to pi by 2 root of sin x by root of sin x plus cos x, or sin x by cos x plus sin x, or sin cube x by cos cube x plus sin cube x, whatever may be the value in this form, the answer you are going to get is pi by 4. That's it. Very important. So you may expect this for 6 marks. Okay. Let us come to the next problem. Next property, property number 5, that is P4. 0 to a f of x dx is also equal to 0 to a f of a minus x dx. This is same as that of the previous. This is a special case of previous property. So you can start with the RHS. RHS. Let us do the proof. Let us take RHS. RHS is nothing but integral 0 to a f of a minus x dx. Now let us write, put t is equal to a minus x. Differentiate it. dt by dx is equal to a is 0, differentiation of x is 1, dt is equal to minus dx or minus dt is equal to dx. Now, as you know, whenever the substitutions are taken, the value of limit also changes in definite integrals. When x is equal to lower limit, what is the lower limit? 0. When x is equal to 0, t is equal to a minus 0 is a. Again, when x is equal to a upper limit, t is equal to a minus a is 0. This given integral reduces to integral 0 to a. 0 to a becomes a to 0 f of a minus x is t into dx. What is dx? dx is equal to minus dt. That's it. See here. 0 to a f of a minus x dx. 0 to a reduces to a to 0 f of a minus x is t and dx is equal to minus dt. You can take negative sign out. Minus a to 0 f of t dt. Again, according to the property, integral a to b f of x dx is also equal to minus b to a f of x dx. If you interchange the lower and upper limit, the integral will reduce us to negative. So minus becomes plus, a to 0 becomes 0 to a f of t dt. Again, according to the property, again first property, if you change the variable a to b f of x dx is also equal to a to b f of t dt according to property number 1. So 0 to a f of t dt can also be written as 0 to a f of x dx, which is the required LHS. 0 to a f of x dx is equal to 0 to a f of a minus x dx. Followed. Very important. Very important. You may expect this also for 6 marks along with one example. See, let us write RHS. RHS 0 to a f of a minus x dx. Put t is equal to a minus x. dt is equal to minus 1. Minus 1 into dx is dt, or minus dt is also equal to dx. Whenever the substitutions are taken, the value of limit changes. When lower limit x is equal to 0, t is equal to a minus 0 is a. When upper limit x is equal to a, t is equal to a minus a is 0. This reduces to a to 0 f of t and minus dt. F of a minus x is t, dx is equal to minus dt. You can take minus out, a to 0 f of t dt. According to the property, if you interchange the lower and upper limit, then this reduces to plus, a to 0 becomes 0 to a f of t along with positive sign. Then according to first property, integral a to b f of x dx is also equal to f of t dt, interchanging the variables. 0 to a f of x dx, that is the required LHS. Followed. This is also a very important property. Now, let us take few problems based on these properties. Now, evaluate minus 1 to 2 x cube minus x dx. What is the interval given here? The interval is closed interval minus 1 comma 2. Let us split this interval. So, when x is in minus 1 comma 0, this equation x cube minus x is greater than or equal to 0. So, in the interval minus 1 to 0, x cube minus x is greater than or equal to 0. This can be written as minus 1 to 0 x cube minus x into dx. Plus second part, when in the interval x 0 comma 1, x cube minus x is less than or equal to 0. Between 0 to 1, this is less than or equal to 0. Therefore, this can be written as less than means minus of x cube into dx. Plus, and the last interval, what is the last interval? In between, in the interval 1 comma 2, x cube minus x is again greater than or equal to 0. This x cube minus x is greater than or equal to 0. Therefore, this can be written as interval 1 to 2, x cube minus x dx. That's it. Evaluate this. So, the split of integrals is minus 1 to 0 x cube minus dx plus minus of x cube minus x dx between the limits 0 to 1 and again 1 to 2 x cube minus x dx. Integrate it, you will get the answer. That's it. This can be written as minus 1 to 0 x cube minus x dx, minus into plus minus 0 to 1 x cube minus x dx plus 1 to 2 x cube minus x dx. That's it. Evaluate it, you will get the answer. Now let me integrate this. What is this equal to? The integral of this x cube is x to the power of 4 by 4 minus integral of x is x square by 2 limits minus 1 to 0 minus integral of x cube is x to the power of 4 by 4 minus x square by 2 between the limits 0 to 1 plus integral of x cube is x to the power of 4 by 4 minus x square by 2 between the limits 1 to 2. Now let us apply the upper and lower limit and simplify it. Now let me apply the upper limit. Upper limit is 0. 0 minus anything is 0. I will go to the next page. This is equal to 0 minus, what is the lower limit? Minus 1. Minus 1 to the power of 4 by 4 minus 1 to the power of 2 by 2 minus, again upper limit is 1, lower limit is 0. This can be written as 1 to the power of 4 by 4 1 square by 2 minus 0. Okay, plus upper limit is 2, lower limit is 1 plus 2 to the power of 4 divided by 4, 2 to the power of 4 by 4 minus 2 square divided by 2 minus lower limit is 1, 1 to the power of 4 minus 1 by 2. Simplify this. So if you simplify this, you will get the answer. This is minus as it is 1 by 4 minus 1 by 2 minus 1 by 4 minus 1 by 2 plus this is 2 to the 4, 2 to the power of 4, 2 to the 4, 4 to the 8 to the 16, 16 by 4 is 4 minus 2 square is 4 divided by 2, 4 divided by 2 is 2 minus this is 1 by 4 minus 1 by 2. Simplify this. This is minus of, take LCM, 4 is the LCM, 4 4 gets cancelled, 1 minus 2 minus of, again 4 is the LCM, 4 4 gets cancelled, 1 minus 2 plus this is 2 minus, take LCM, 4 is the LCM, 1 minus 2. Now this is equal to, this is minus of 1 minus 2 is minus 1 by 4 minus 1 minus 2 is minus 1 by 4 plus this is 2 minus 1 minus 2 is minus 1 by 4. Now this can be written as minus into minus plus 1 by 4 minus into minus plus 1 by 4 plus, take LCM here and simplify. 4 is the LCM, 4 2s are 8 minus into minus plus 1. So this is nothing but 1 over 4 plus 1 over 4 plus 8 plus 1 is 9 by 4. Now take LCM. 4 is the LCM. 4 4 gets cancelled, 1 plus 1 plus 9. That is 9 plus 1, 10 plus 1 is 11 by 4. The required answer is 11 by 4. That's it. So the answer is 11 by 4. Hope you followed this. Okay, let us come to the next problem. This is also a very important problem. Integrate, evaluate 0 to pi x sin x divided by 1 plus cos square x. Now according to the same property, let us write let I is equal to integral 0 to pi x sin x divided by 1 plus cos square x dx. Let us represent this as equation number 1. Change or put change x to upper limit minus x, pi minus x. Then this becomes 0 to pi. X is nothing but, what is x? Pi minus x into sine of pi minus x divided by 1 plus cos square pi minus x into dx. Now you know the formula is, what is sine 180 minus theta? Sine 180 minus theta. Yes, it comes in second quadrant. In second quadrant, sine is positive. It remains the same, sine x. Sine 180 minus theta is sine theta. And what is cos 180 minus theta? It is minus cos theta. So this equation reduces to I is equal to integral 0 to pi this pi minus x as it is, keep pi minus x as it is, and sine 180 minus theta is sine theta, this becomes sine x into dx divided by, in the denominator, 1 cos 180 minus x is minus cos, minus into minus, minus square, it becomes plus cos square x. Now this can also be written as split, multiply this, 0 to pi, pi into sine x dx divided by term division, 1 plus cos square, minus integral 0 to pi x sine x dx divided by 1 plus cos square x. Now this can be written as I is equal to pi out integral 0 to pi sine x dx divided by 1 plus cos square x minus x sine x by 1 plus cos square x is nothing but I. This is I from equation number 1. Now just evaluate, you will get the answer. That's it. Okay. Now listen to me once again. Change x to pi minus x, upper limit minus x. So x is pi minus x into sine pi minus x divided by 1 plus cos pi minus x. This is same pi minus x. Sine 180 minus theta is equal to sine theta divided by 1 plus cos 180 minus theta is minus cos. This is square, minus square becomes plus 1 plus cos square. Now multiply by sine x, pi into sine x divided by term division, 1 plus cos square x dx minus x sine x dx divided by 1 plus cos square. This pi can be taken out, and this 0 to pi x sine x dx by 1 plus cos square x from equation number 1, it is I. So transfer this minus I to left hand side, it becomes I plus I. I'll go to the next page. I plus I, this is 2I is equal to 0 pi into 0 to pi, what is there in the numerator, sine x dx divided by denominator 1 plus cos square x. Now integrate this, you will get the answer. That's it. How to integrate this? This can be integrated by the method of substitution. Now let us take put t is equal to cos x. Differentiation of cos x is minus sine x dx, or minus dt is equal to sine x dx. Further, whenever the substitutions are taken, the value of limit changes. When x is equal to 0, lower limit, t is equal to cos 0. What is cos 0? Sin 0, 0, cos 0 is 1. When x is equal to pi, t is equal to cos pi, cos 180. Cos 180 is minus 1. This given integral reduces to pi into 0 to pi becomes 1 to minus 1 sin x dx. Sin x dx is nothing but minus dt divided by 1 plus t square. Cos square is t square. So therefore 2I is equal to pi into, just take minus out, integral 1 to minus 1 by 1 plus t square dt. This is integral 1 over a square plus x square dx is equal to 1 over a tan inverse of x by a plus c. This is 1 by 1 is 1 minus pi into tan inverse of t. Between the limits, what are the limits? 1 to minus 1. Now this is minus pi, 2I is equal to minus pi into, apply the upper limit, tan inverse of minus 1 minus tan inverse of plus 1. This is minus pi into tan inverse of 1 is minus pi by 4 and plus pi by 4. This is 2I. 2I is equal to minus pi into pi by 4 minus pi by 4 is minus pi by 2. So this can be written as minus into minus plus pi square divided by 2. So therefore I is equal to, bring this 2 to the denominator, pi square by 4. The answer is pi square divided by 4. The simplified answer is pi square divided by 4. That's it. Followed. This is very important and easy problem. If you solve this much, you will get 6 marks. Property and an example. Okay, see, put t is equal to cos x, differentiate it. You will get sin x as minus dt, 1 by divided by 1 plus t square, and 0 to pi reduces to 1 to minus 1. Take pi out. The integral 1 over a square plus x square is tan inverse x by a. Tan inverse of minus 1 is minus pi by 4. Tan inverse of 1 is pi by 4. Minus pi by 4 minus pi by 4 is minus pi by 2. 45 plus 45 is 90. Minus pi by 2. Minus into minus plus pi square by 2. Transfer 2 to the denominator. This becomes pi square divided by 4. So, the simplified answer is pi square divided by 4 is the integrated answer. That's it. Okay. Hope you followed. The answer for this is pi square divided by 4. This is a standard question. Okay. Now, that's regarding this session. Let us discuss few more properties in the next session. That's all for today's session. We'll meet in the next session with different remaining properties. Thank you very much.